Hi everyone, Danielle here. I'm so grateful I get to present this and combine two topics that I like, science and cybersecurity. Thank you so much, Digital Overdose team. It's wonderful and helpful this thing that you do for rookie speakers. I remember my first CTF2 was with Digital Overdose, and I remember being teammates with Denise. So I'm really thankful that a lot of my cybersecurity first milestones are with Digital Overdose. Shifting careers, it felt like foreign territory. Being in the chemistry lab in my undergrad days, it felt like there isn't much about cybersecurity that would resonate or overlap with where I came from. But in my journey as a beginner, or as I would proudly say, a script kiddie, which is new to all of these, the overlap between those two fields has been really fascinating to discover. But before my presentation, just a quick introduction. I'm Danielle Arcon. I'm a Christian from the Philippines. I majored in biochemistry, but I'm also an enthusiast of cybersecurity. I really enjoy these shows. Some of them make me wonder, some of them make me curious, some of them make me laugh. And there's a chance you'd find some of them among the slides. And yeah, that's a short introduction about me. And with this cue from Dr. Matjimi, let's jump to the main part. Your presentation really is inspired by biomimicry. That is to say, the emulation of examples from nature, environment, and basically the natural world to solve complex human problems. We've seen humans take notes from nature and copied solutions for our architecture, fashion, and biomedical engineering. Velcro is among such examples. Mosquitoes were also studied in research as models for an effective needle in medicine. But there are a couple more examples in the industry where commercial problems are solved by mimicking nature. Like, a new batch of solar cells have taken an inspiration from plants. The solar cells mimic a mechanism used by plants to generate energy through photosynthesis. So the dye-sensitized solar cells, or DSSCs, contain a porous layer of titanium dioxide nanoparticles covered in a dye, and that absorbs incoming photons from the sun, just like the way plants absorb light for photosynthesis. And these solar cells are generally considered much more environmentally benign to produce than traditional solar cells because they use relatively non-toxic materials that require only little energy to manufacture. They're also able to produce the same amount of energy as a silicon-based solar cell while reducing their life cycle environmental impact. And another example of biomimicry is for their products harnessing the example of coral reefs to sell eco-friendly concrete. So the process of making cement, one of the main ingredients for concrete, it's responsible for about 6% of all man-made carbon dioxide emissions. So those gases absorbing solar energy and they keep heat close to the earth, that's known as the greenhouse effect. And that leads to global warming. So this company, Forterra, they mimic the formation of coral reefs by using the carbon dioxide emissions from power plants, which is then channeled into salt water, also waste, and the product that is formed is used as cement and other similar products. Basically, the solution they contribute is that rather than releasing carbon dioxide with the production of cement, they use it instead as an ingredient. They claim that for every 1 ton of cement they produce, they remove 1 ton of carbon dioxide that would have ended in the atmosphere. And another example is the Kingfisher inspiring the Shinkansen bullet train in Japan. The engineers looked to nature to redesign the bullet train. So they noticed how the kingfisher birds are able to slice through the air and dive into the water to catch prey while barely making a splash. They then redesigned the front end of the train to mimic the shape of the kingfisher's beak. And not only did this help to reduce noise and eliminate tunnel booms, it also allowed the train to travel 10% faster, using 15% less electricity. And there we've seen a few examples of how engineers and scientists copy some notes from nature. But what about in cybersecurity? When defense is a topic in cybersecurity, how is that similar with the body's own line of defense, the immune system? As it turns out, the steps of incident response in cybersecurity has some stuff in common with our own anatomy's immune response when we are faced with a pathogen or an invader. So, simply put, we can simplify the immune response with this four bullet points: prevent, recognize, counter, and then we recover and we recall. When we say prevent, those are the protective measures we have ready in place to block an attack. Physically, we have these barriers like our skin and membranes to make a boundary between external and internal environment. Our saliva itself has antibodies. And with our tonsils location, they can stop germs entering the body through the mouth or the nose. And of course, we have several measures as our lines of defense in place to strengthen our own cybersecurity posture. But when that is bypassed, when our gates are breached, when we need someone to flag that we have been attacked, despite the barriers, pathogens may enter the body through skin abrasions or punctures, or by collecting on mucosal surfaces in large numbers. We need someone to alert us about the danger. And despite the strength we think we have in our cybersecurity policies, there might be a back door we do not expect. Inside the body, we detect protein molecule signatures of the invader, and that distinguishes them as attackers. These are our markers because their signature differs from those on the host cells from our own. And that isn't too different as well with us detecting signatures with malware or malicious files. So when that's done, once we already recognize that there is an attack, beyond just detection, we react. Now, depending on your incident response plan, you react as needed on the context. You can isolate the server, you adjust routing policies, or delete malicious software or artifacts that were left. You get rid of it. And as for the body, our cells ingests the enemy and kills that. Kind of the way we see phagocytosis taking place here and here. But it's not just important that we recognize and then we react. We should also prevent the same invaders from causing huge damage again. Our body learns from those and adapts. We classify that as our adaptive immunity. We have memory lymphocytes, and they react faster when an attack repeats because they've also encountered in the past who they're dealing with. We also learn from events, so we patch. Machine learning is also frequently mentioned as a helpful solution. Yu and his colleagues suggest parallel adversarial network. They propose a PAN, the parallel adversarial network, that accompanies the operation network, because that would share the same physical network resources by using network slicing techniques. And in the PAN, they can proactively introduce controllable attack and viruses. They can also use machine learning methods to make attack and viruses mutate automatically. And by doing that, it is possible to observe, identify, evaluate, and assess network vulnerability. So ultimately, they can produce network quote unquote vaccines for defense, similar to vaccines in the immune system. And during times of COVID, we also hear about herd immunity being mentioned quite often in terms of vaccination. And the gist basically is to use the influence of quantity to minimize the risk of the disease on vulnerable groups. So when there are more individuals with immunity, this indirectly protects other at-risk individuals within the vicinity too. And The same goes with cybersecurity. Cyber attacks demonstrate, especially with supply chain attacks, that businesses are connected. Cyber risk is not just a them problem, it's a we problem, no matter how strong we think we are. The recent string of high profile ransomware incidents have taught us that even the most astute analysts, hunters, or best in class technologists cannot fully protect networks alone. Defending alone isn't enough anymore. It's vital for organizations to act proactively to better position themselves for staying ahead of cyber attacks. And that starts by investing in the right network detection and response solutions and joining forces with industry peers, especially fellow targets of the same attacker, to improve the clarity of the threat landscape. We have seen the rise of numbers in cyber attack during the pandemic, and perhaps, just like those engineers and those scientists, we can copy some of nature's notes too. Because we are profoundly connected, such that we are most protected when we also protect others. So, the reason I wanted to talk about the intersection of immunity and cybersecurity isn't just because the guy playing Mr. Robot would apparently make a convincing doctor. Not because I wanted to talk about the obvious. Because none of this is novel information. Machine learning, cooperation among industry experts, and different adversarial networks are already known, and those are not new concepts. Some of those you probably already know much better than I do. But I wanted to talk about the overlap in the fields of science and cybersecurity because despite the polarizing opinions or big differences we might have, we still have more common than we think or notice. We're used to the word network, but I hope we never get numb to the beauty of that word in nature. Our ecosystem is an intricate, beautiful network that helps sustain our survival, where even a small insect can affect the food chain that affects animals greater than 100 times its own size. Networks in our own body, in our own mind, that look even better than science fiction. And of course, the human network where some would say many cybersecurity errors come from, the human element of breaches, others would like to call it, but nevertheless the same human element that uses machines as a transformative instrument to connect, empower one another, and as this digital overdose event would show, it links people, no matter how different, from across the globe and varying time zones, you and I, to talk about shared passions and what we have in common. Thank you so much, everyone. Thank you. I really appreciate the opportunity to talk about this. Thank you. Thank you.